Yes, good morning, students. So, continuing with the next class, that is the Ethernet. So, now here we are going to see about the addresses. So, in Ethernet, host in the world as a unique Ethernet address. Any host which is connecting here to that particular network, is it clear? So, it is having an unique address. This unique address we are going to be called as a physical address or called as a Ethernet address. Technically, this address belongs to the adapter, not to the host. Technically, if you wanted to tag, so manufacturer is going to put this particular address during the manufacturing of this network adapter. Is it clear? So the address which is presented in the network adapter is unique throughout the world. It is usually burned into the ROM, read-only memory. So Ethernet addresses are typically printed in a form where humans can read. Is it clear? So is it possible to read Ethernet address? Yes, it is possible to read the address. It is going to be printed in a form where humans can read. So it has a sequence of 6 numbers separated by the colon. So here I am going to show you. It is having a 6 numbers separated by a colon. Each number corresponds to 1 byte of the total 6 byte address. So totally how many bytes are there to represent the Ethernet address? 6 bytes are there, which a manufacturer is going to put this Ethernet address in the adapter, and that adapter is connected to the computer. It is related to the adapter address, and now here it is that 6 bytes is used to represent that particular the address. We call it as the Ethernet address. So how many numbers you are going to represent? 6 numbers, each one is separated by the colon. For each number 1 byte is used to represent. Okay, and next one, each number is going to be represented with a pair of hexadecimal digits. You just see 2b, e4, b1 they have written. So that is a pair of hexadecimal digits. Okay, each one is going to use a 4-bit nibbles in the byte. Is it clear? So each one is going to be using a 4-bit nibbles in the byte. So totally 6 numbers are there. Each one number is going to be represented with a 1 byte. So in that particular 1 byte, so that is a 4 that is a 4-bit nibbles is used to represent a 1 hexadecimal number. So 2 hexadecimal digits are going to be represented under this 1 section. Is it clear? So now this is the example here. You just see that 8 colon 0 2b colon e4 colon b1 colon 2. This is a human readable representation of the Ethernet address. So you just count it here. How many numbers are 1 2 3 4 5 and 6. Okay, each one is going to be representing with a 1 byte, and with the 2 hexadecimal digits are there. That is a 4-bit nibbles for each number. So this is how you are going to representing this. So this is the below one. This one is going to be represented in a binary. Okay, so this is about that particular the Ethernet address. Now how these particular Ethernet addresses are generated, everything is available in the notes. You please go through it. That is the prefix is going to be given to the manufacturer, and the manufacturer is going to use it prefix, and then he is going to generate a unique addresses for all the network adapters which is going to be manufacturing. Okay, so the next one here it is that Ethernet frame. Is it clear? Whatever you are going to be transmitting. So now you are just going to summarize that an Ethernet adapter is going to receive all frames and accepts. So here is the list that what type of the frames are going to be received by the Ethernet adapter. The frames which is addressed to its own address. Is it clear? Any frame which is arrived with its own address, that its physical address is present on that particular frame, then it is going to receive it. Any frame which is a broadcast address, a frame which is having a broadcast address, that it should be received to everyone presented on the network. The broadcast address is present at that time, this frame Ethernet adapter is going to receive that frame. The next one, a frame which is going to contain the multicast address. Is it clear? So what you mean by multicasting? Was sending the frame to some group of hosts only. Is it clear? So the group of nodes which are connected in the network, not all the nodes, only to the selected nodes you are going to be transmitting. That is what called as a multicast address will be there. If the multicast address is there, then also network adapter is going to receive it. Is it clear? All the frames it has been placed in the Prometheus mode. So in which case it delivers all the received frame to the host. Is it clear? It passes to the host only the frames that it accepts. Is it clear? So it is going to transfer this to the host only the frames which it is going to accept. Now we are going to see about the algorithm, that is transmitter algorithm. Okay, so the transmitter algorithm is defined as follows: when the adapter has a frame to send, and then it is going to check that whether the line is ideal or not. If the line is ideal, then only it is going to transfer the frame immediately. Is it clear? There is no negotiation with the other adapters. It is not going to make any negotiation with the other adapters. Just simply it is going to check that whether the line is currently busy or whether it is ideal. If it is ideal, immediately it is going to transfer the frame to the network. When the adapter has a frame to send and the line is busy, at that time what it has to do? It has to wait for some particular time period, that is until the line go ideal, and then transmits immediately. So this is the process here which it is going to do. Now this process here, what you are going to be call it as a, said to be a one persistent protocol. Okay, so there are different media access control protocols are there. Actually it is not for your syllabus. That is a initially in the olden days we were having a pure ALOA, slotted ALOA will be there. Is it clear? Next in this only persistent algorithm, different persistent algorithms are there. One persistent, n persistent, p persistent algorithms are there. So this is the Ethernet is going to using the one persistent protocol. So what is this one persistent protocol? That adapter with a frame to send transmits with a probability 1. Is it clear? Whenever a busy line goes ideal. So this is the one persistent. The node who is having a data to transfer, it is going to sensing that channel. So as the channel becomes free, it is going to transfer the same, but the probability is only one, that only one node on the network is having or able to send the data and any given time when the line goes ideal. If more than one node transfer the frames, immediately collision is going to be occur. So that's why here they are going to be called as a one persistent protocol, that is adapter with a frame to send or transmits with a probability is only 1. Is it clear? That is the probability is only 1 when a busy line goes ideal. So the Ethernet adapter always transmit immediately after noticing that the network has become ideal and has been very effective in doing so. So Ethernet, there is no centralizer control. Okay, so it is possible for two or more adapters to begin transmitting at the same time, because whenever they found that line is ideal, whenever the nodes are having a data, okay, so all these nodes are going to be checking that to become that the line should become ideal. Okay, and immediately they are going to transfer the data. You are not having any particular centralizer control for that. When more than one node simultaneously transfer, so there is a chance of the occurrence of a collision. Okay, that is the two or more frames are said to be collide on the network. Now each node is able to determine, that is the sender is able to determine that a collision is in progress. Okay, so Ethernet supports the mechanism called as a collision detection. So each the sender will having a mechanism to detect that whether the frame transmitted is collided with the another one frame transmitted by the another node on the same network. Okay, so that it frames is colliding with the inner, it first makes sure to transmit a 32-bit jamming sequence. Immediately what it is going to do, if it has detected that this frame has been collided with the another one, immediately it is going to transfer the jamming sequence. So that is the 32-bit jamming the sequence. Okay, and then stops the transmitting. A transmitter will minimal send, okay, 96 bits in case of the collision. Whenever a collision is detected, minimum number of that the bits it has to send is a 96 bits. Why? Because 64 bit is a preamble plus 32-bit is a jamming sequence. So total number of bits it has to be sent. So that is nothing but a 96 bits. Okay. So when the adapter will send this 96 bits, which is we are going to be call it as a runt frame. Whenever the adapter detect that particular collision, so it is going to transfer which frame? That is a runt frame is going to be transmitted. Is it clear? To know for sure that the frame it just sent did not collide with another one frame, okay, the transmitter may need to send as many as 512 bits, that is the 64 bytes. Is it clear? That is the 14 bytes of the header plus 46 bytes of the data plus 4 bytes of a CRC. This is the minimum. Okay, the next one here we are going to see this example of this the collision here. Okay, now in this example here we are going to be say that this is the one Ethernet segment. Okay, so two nodes are going to be connected here. One is a node A, another one is a node B. So A sends a frame at a time t. A sends a frame at a time t. Is it clear? Now the next one here it is that you see that second one here it is that A's frame arrive at B at a time t plus d. Okay, when A frames arrives at the destination side B, at that time the time will be t plus d. That is the d is nothing but the delay or the latency, or that is the time taken by the frame to move from A towards or A to B. That is what we call it as the delay or the latency. So when the A's frame arrive at B at that time, the time will be t plus d. Is it clear? Now B begins transmitting at the time t plus d. Okay. Now at the same time, okay, when that A's frame is arriving nearer to B at the time t plus d, it check that line. Still that the signal has not received by the B. Still it is ideal. Immediately it is going to transfer the frame at the time t plus d. Is it clear? Now here B's frame and A's frame are going to be collide with each other. Okay, a collision is going to be occur nearer to the node B. Is it clear? So the collision is going to be detected by the nodes where the nearer nodes where the collision is going to be occurred. It is just like that somewhere else if accident has been happened, the people nearer where they are living, the people immediately first know about that accident and they try to inform the information to their parents. Okay, so this is also the same thing, is that the node which is nearer to the collision, okay, immediately it is going to detect because there is a the huge change in the signal. Okay, so immediately it is going to identify it, yes, the collision has been occurred here, and immediately it is going to be sent a one runt frame. Okay, when this runt frame is going to be reached to the A, now what it is going to be do? Suppose that A begins transmitting the frame at a time t as shown in the figure A. So all these things already here I have explained. So directly I will come to the last point, that is host B will send the 32-bit jamming sequence when B's frame will be a runt. Unfortunately, host A will not know that. Still host A doesn't know that the collision occurred until and unless it receives the runt frame transmitted by the B. When A receives the runt frame transmitted by the B, A will come to know that its frame has been collided with the B's frame. At that time, the time will be T plus 2 into D. Is it clear? So, time will be T plus 2 into D. That is a two-way latency. Okay, a host A must continue to transmit until this time in order to detect the collision. Otherwise, host A must transmit for 2 into D to be sure that it detects all the possible collisions. Okay, so this is all about that how A come to know that a collision has been occurred when it has received the B's runt frame, and when it receives the B's runt frame, immediately it stop transmitting here, and it is going to be wait for some particular time period, and after that once again they are going to be sense the line. If the line is free, then they are going to be transfer. Now the question is going to be raised. Is it clear? How long you have to wait? Is it clear? How long you have to wait? Here, that is an Ethernet is of 2500 meter long, and 4 repeaters are there. Okay, and the round trip delay between the any two hosts is already they have been determined, that is RTT, that is the two-way delay. Is it clear? What is the RTT? RTT is a 51.2 microseconds will be there, okay, on a 10 Mbps Ethernet line. So whenever the node detect that a collision has been occurred, it has to wait for the RTT time period, that is a 51.2 microsecond. It has to wait, and after that once again it has to check whether the line is free. If it is free, then it has to start transmission. If the line is busy, now what it has to do, it has to double the amount of time it has to wait. That is now 2 into 51.2. Is it clear? So after the completion of this third time, once again it is going to check whether the line is free or whether it is a busy. At that time also, if it find that if the line is busy, now once again the waiting time is increased, that is a 3 into 551.2. Is it clear? So in generally I am going to be write it the formula, that is a k into 51.2. Value of k is going to be started from 0, 1, 2, 3 and so on. Is it clear? So that is it is going to be started from k is equal to 0 and 2 raised to 3 minus 1. Okay, here it is that, okay, for the k is equal to 0, 1, 2, 3 and 0, 1, 2 raised to 3 minus 1. So now this the process of the waiting here, which you are going to be called doubling the delay, you are going to be call it as the exponential back off. Is it clear? The strategy of doubling the delay interval between each retransmission. So this technique of doubling the delay, we call it as a exponential back off. Okay, now the question is raised once again, how many number of attempts the node has to be try for the transmission, how many number of times it has to go for the backup. Maximum number of times, okay, an adapter typically retrieve up to 16 times only. Maximum times it can go, it can try for a retransmission. So maximum is 16. So 16 times if it fails to transfer, every time it is failed, if it has find that a line is busy and all, okay, so it stops the transmission and then it is going to generate the error message. Okay, so this is here all about the Ethernet. Okay, so we have completed everything about the Ethernet. Okay, so here it is experiences with the Ethernet. So this is a summary will be there. So I will just go through this one, that is Ethernets are used in the for more conservative way than the standard way. Okay, most of the Ethernet have fewer than 200 hosts connected to them. Most of the Ethernets are far shorter than the 2500 meters, and the delay, round trip time delay is just closer to the 5 micros instead of a 51.2. Ethernet is extremely easy to administer and maintain. Ethernet is inexpensive. Cable is cheap. Okay, and only the other cost is a network adapter on each host. Okay, so these are all some of the points are there. So this completes about a Ethernet. Okay, yes, thank you very much.